Let's do it. It's go time.
Welcome to Go Time, your source for wide-ranging discussions from all around the Go community. Find us on the web at gotime.fm, on the Fediverse at GoTime, at changelog.social, and on X at GoTimeFM. Thanks to our partners at Fly.io, the home of changelog.com. Launch your app as close to your users as possible. Find out how at Fly.io. Okay, here we go.
Welcome to Go Time. It's yet another week and yet another episode, and I am your wonderful host, Kris. And today we are talking about supply chain security and dependencies. And joining me for this episode, we have Ian and Johnny. How are you doing today, Ian?
I'm doing great.
Awesome.
Can't complain.
Nice. How are you doing today, Johnny?
I'm checking to see if anything we use has anything to do with polyfill or just gonna quick check. That's how I'm doing.
Just a little check, like a little grep of the code base. So today what we're talking about is a few things, but first up, we're going to talk about this vulnerability, I guess, or this compromise, one could say, of polyfill.io. Ian, do you want to give the listeners a quick summary of what happened?
Yeah, sure. So polyfill.io is a CDN that serves a JavaScript library for, browser polyfills. And a couple months back, the maintainer of the JavaScript library warned not to use the polyfill.io CDN, which he does not own and isn't associated with because it was sold to a different company. And just now they started injecting malicious JavaScript, and it affects hundreds of thousands of websites like Hulu and JSTOR, however you say that, all kinds of sites. They got caught redirecting to gambling sites and all kinds like that. So it's a pretty big deal.
So as you were saying that, I'm thinking, okay, CDNs, like the especially in the front end community, pretty much CDNs are like they reign supreme, right? Like usually, any libraries, JavaScript libraries that you're using to build sort of your apps or even sort of shipping stuff, like there's usually a CDN URL because that's the best practice, right? The CDNs are distributed all over the world, and your users are going to be close to hopefully one of those endpoints, and that means your website, your app loads up that much faster, right? That's the value of CDNs. But I don't think anybody ever stops to, or rather, not that they don't, but I don't think people tend to pay close attention to CDNs because they're kind of like, they're always there. They're gonna always work. Or, it's you see a link to I'm gonna date myself here, like a Bootstrap CDN thing, and you just copy and paste it, and you're good to go. Now you've got Bootstrap, right, or whatever library of choice you're using. It's one of those things like you just assume that somebody's footing that bill. I don't have to worry about I don't have to worry about it. I just include it in my JavaScript or in my app, and off I go. So it's kind of interesting that now you have, through a change in ownership of a domain name, you've got this thing popping up. How interesting. And again, within the NPM, that's not an NPM only thing, right? It's anybody that uses that polyfill. But I assume that it's libraries that are served up. It's JavaScript libraries that are primarily affected by this, right?
Yeah.
So not even JavaScript libraries. I mean, it's at least for this specific attack, it's just anyone that includes this, right?
Anyone, anybody.
I mean, it's like if jQuery or Google Analytics was
compromised.
Compromised. How many sites would that affect?
I think it's interesting that one of the biggest advantages of any of these CDN, especially like the front end CDN providers, is that you have, if everybody's using the same one, then there's a good chance that whatever library you're using, whatever code you're trying to pull in is already cached. So there's not even a request that happens to the CDN. So it's super fast. But that also makes them huge targets for attack because it's included on so many websites. So if you just make a small change there, if you get in there, you can compromise a gigantic number of websites. But it also kind of feels like CDNs are at least a little bit a relic of the past in some ways. Like, I mean, obviously not CDNs in total, but CDNs for this specific purpose. In the same kind of way that like I've kind of come to see that having different subdomains for your assets is kind of a relic of the past. When we're all HTTP 1, we can only have 6 connections at the same time, and you wanted all your assets to load faster. And it's like with HTTP 2 and 3, we don't need that as much. And usually you can compress a lot of the stuff down to be really small, and it's only going to be the first page load where it gets hit. So it feels like perhaps some of the reason why we keep using so many of these CDNs is because we're just so used to it instead of actually needing to use it, especially if you're like a smaller site or something like that. So if, this is something, if you want to think about being more secure in the future, you could also always think about just not using a CDN and serving it from your domain directly with the rest of the stuff that you have, or like using Google.
So if you're a Go developer, how does this affect you? Or does it?
It doesn't, but
Not directly.
But the idea of like these supply chain attacks, I mean, does affect you as a Go developer. I think Go's done a lot to make it so we don't have to think about that as much, but it is still something that should be thought about. We've seen other like pretty crafty supply chain attacks, like even this year. If you've seen the what's the library card called? The compression library.
Oh, XZ.
Yeah. If you've seen the XZ attack, that one was actually someone basically bullied a maintainer and said they weren't updating stuff fast enough and got themselves in as a maintainer. And then like slowly over years committed different pieces of code that eventually got to this exploit, right?
That is sophisticated.
It is sophisticated.
I mean, who's to say the bullier didn't get bullied into giving their, GitHub
That's
handle
true.
or whatever it is, right? So it might not even have been the original.
Well, I mean, based on the length of the attack, yeah, but
right, yeah,
100%.
it might have been, yeah.
Yeah, we don't know. But I mean, do you guys like think about the I don't know, the supply chain when you're deploying things and building things?
So thankfully, I'm not loading things up at runtime. Like even if I was serving up like an app, right, through like you can serve up a web app, right, through Go, right? You can just set up an HTTP server, serve up a static site, whatever it is, right? So in a way, if you were serving up a website through Go and part of the HTML or JavaScript that you're loading and serving up to the client includes a library that you're loading at runtime that points to a polyfill CDN, you could be affected, right? That's a direct way you could be impacted. So your Go code is not being affected, but the front end that you're serving that includes this, a library from that CDN could be affected, right? So for Go itself, like I rely on sort of the guarantees, or rather the steps that the Go team sort of have taken to ensure that the things that I'm shipping as part of my binary are indeed what I think I'm shipping, right? And I think you linked out the list of things that we do, sort of how do we mitigate supply chain attacks in Go. So this was a post from Filippo Valsorda back in 2022. And we'll link that in the show notes, right? So basically from the locking of the builds, right, the versioning of the builds, to the contents of the build, the dependencies themselves, right, never changing because we're using that checksum database, to using your repository, right, the commit hashes, right, as a source of truth. And building code and sort of just building doesn't execute code, right? There are certain attacks that can come from that, right? And also, generally speaking, within the Go community, I think we go to great lengths to sort of not include sort of random packages, right, into our programs left and right. At least quite a few of us do. I'm certainly very critical of anything I import into my library. Like the notion of a little, copying is better than a little dependency. Like a lot of us in the Go community take that too hard, right? If I just need a quick library to do something, like a quick utility that does something sort of trivial, I'd rather find the library, see how they implemented it, and implement my own version, or literally copy the bits that I need, like with attribution, right? Copy the bits that I need, put it in a package that I control, and I know exactly what's going in there, right? So I think Go developers are very. I think we're. Let's just put it this way, and perhaps that is an unpopular opinion. I think Go developers, on average, are more security conscious, in my experience, than your typical front end developer. I think your typical back-end Go developer is more security conscious than your typical front-end developer. That's my opinion. I'm sticking to it.
I feel like some of this is path dependency as well. Like I've noticed how I've changed over time. Like when I first started writing Go, it was in the bad old days when it was just like, oh, you just go get something and it pulls whatever from, whatever's at the top of master and get, and that's what you get. And if it changes and it breaks something, good luck with that. And so a lot of us, dependencies were in some ways a liability for you, because like if you want to go back and rebuild some old code and you haven't vendored those dependencies or something like that, then you're just, in some cases, you just won't be able to build it. You have to spend hours digging up old commits and carefully crafting your Go path to have just the right things in it. So I think that pushed us as a community to have fewer dependencies and have those dependencies be more stable, and I think in some ways smaller, so that there wasn't that much shifting. And then after that, we got all of these other things that we have with the versioning and the stable builds and all of the cryptographic checks that we have to ensure that things don't change underneath you. I think that just kind of solidified everything. Whereas I think in like the Node world or the JavaScript world as a whole, like their path to all of this was a lot of like just pull in everything. Like don't have not invented here, use proudly found elsewhere. Just like pull in dependencies. If someone's already in it, then you don't need to include it, which is just like a very fundamental, it's a fundamentally different way of viewing your dependencies. And I think those two different paths have led to these two very different places now, which I think in some cases does have Go engineers as a whole be more security focused. But I don't necessarily know if those two things are related as much. I think they're just kind of, there are things that sit next to each other, but I really do think like the big reason why we have fewer of these problems is because we are such a, I guess in some ways, a dependency hostile community. We're like, our standard library is good. Dependencies used to just be a very obnoxious thing to deal with. And that just got solidified into the community for like, the foreseeable future. That could change in the future, but I think if you add in the security stuff, I think that's what solidifies it going forward. Whereas I think if we had been the type of community where we had a package manager at all from the beginning, we might be dealing with the same sorts of problems that, say, the JavaScript community is, or so many other communities are, where like your package management is just kind of chaotic and a mess, and you have to like do all this backfilling to get back to a place that is solid and stable.
We're not immune to like vulnerabilities, right? Like
no,
I keep going back to the notion of the dependencies, and to me, and a lot of these sort of security problems and issues like do come from dependencies, right? It's like every time you bring in a dependency, right, from some third party, whether you're familiar with them or whether you're not, which is most likely you're not, right? Because you might be bringing in a dependency that itself has dependencies. Perhaps you're familiar with the author of the dependency you're bringing in, but you're not familiar with the author or authors of the dependency that dependency depends on. So like at any given turn, you're bringing in a whole bunch of stuff into your world. So what's to stop somebody, now or in the future from actually, having malicious code in it? I mean, think of it this way. Like if I were to have a popular Go package, and I decide one day, or maybe somebody one day gets hold of my GitHub creds or something, and then they decide to sort of update, right, my package to now have maybe use the OS package to slurp up all of the environment variables of the application that you built, that you imported my package into, right? I slurp up all of the OS env. I slurp them all up, and then I send them, or rather, the malicious actor sends them, post all my environment variables to some server somewhere. I mean, that's how trivial it is, right? Literally, somebody could just slurp up all your environment variables, which chances are, if you're following the 12-factor sort of application approach, right, popularized by the Heroku days, right, where you are configuring your application through environment variables and you are storing secrets in there and whatnot, right? Who's to stop somebody from slurping all your environment variables and posting them to some random server because you imported a library that does something you think it does, but it does more than that, right? So things of that nature, which is why I'm very critical of sort of any package I bring into my world and the packages that those packages bring. So usually if I'm seeing lots of dependencies on a particular package, especially if the package is not used very often, right? Or rather, if I can go on pkg.go.dev and I look up a particular package, I have enough metadata on the screen to help me judge, right? I can look at pkg.go.dev. I can look at the top portion. It tells me how many things are importing this package, how many packages does this thing import, right? So these things are factoring into my decision whether to import this package or not, right? Especially if it's a new package, not a lot of activity on it, not a lot of people are importing it, right? But it's importing a whole lot of things, right? Suspiciously doing more than it ought to, right? Or it's on its own surface, right? To me, these are. I'm immediately saying, okay, I need to go to this repository, right? I need to start looking at the code. I need to start seeing what it does, right? Before I bring this thing in. And whatever it does has to be sufficiently sophisticated that I can't quickly come up with it myself, right? So that whole notion of dependencies being able to harm you, that's a very real thing. Because, despite all the checks and balances that we have in the Go community for preventing, malicious code from getting in, if you willingly bring in malicious code in the first place, right? That's on you, right? Because you could have gone and read the code. You could have gone and checked at least to make sure that, okay, this is actively maintained, it's a popular pack, whatever your criteria for selection is. It's on you to put in some effort to do that. Now, we're not all sort of, we're not perfect, and some things could fall through the cracks, but it should be a habit for you to be reading, right, repositories and source code. And obviously, some libraries are large, right? You can't do that, but you can rely on sort of some anecdotes. You can rely on basically how many people are using this thing, how long has it been around, right? Is it being maintained, right? You can rely on those signals to help you, with your dependencies. So to me, dependencies, just picking them up left and right and putting them in your Go program, that's a big no-no for me.
I do think this was a controversial opinion, or I guess like minimal version selection was controversial when we were doing all this package management stuff. But I do think it helps in these cases, right? Like, it makes updating to newer versions of your dependencies and the dependencies your dependencies depend on slower, right? Because it's bringing in the minimum version it can. But I do think that's safer, right? Like, versions aren't getting updated to new versions that might have malicious code. I don't know. I think that's interesting.
And I guess it depends on like what the update. If the update is to fix some vulnerability, then you definitely don't want some old version.
Yeah, it's kind of a double-edged sword here, right?
But then who's going and checking every single update across every single package that they're importing into their program?
Yeah.
If it's sufficiently large enough of a project, right? Are you really going through like? And I'm saying this fully knowing that I myself do this. I will update dependencies, hopefully to sort of a minor version, like to hopefully catch patches and security updates and things, not necessarily jumping to the next feature branch or whatever feature version. But it's a sufficiently large enough project. Are you going through and checking to see all the commits and that they are secure and not bringing in malicious stuff?
I feel like for some things, like, I mean, I don't necessarily, if any package is sufficiently large, I kind of rely on like the Wikipedia effect of things where like, if there's enough eyes on it, if there's a problem, that'll probably get surfaced pretty quickly. It's those like slightly smaller packages that aren't used by a ton of people, but used by some. That's just like, okay, that's the danger
Suspect.
area. Yeah. So it's like, if it's a giant thing and there's enough people looking at it, then I'm not going to be as worried, because even though that's a bigger target, the speed at which a vulnerability will be found is just much faster than other things. But I do think like, I've kind of been on this path for a while of just not really liking that so much of software engineering has become configuring dependencies instead of building stuff yourself. Like, and I think that's definitely an unpopular opinion of like, you should try and build most of the stuff that you need yourself, or at least you should understand how it works enough that you can go read the code and make sure it's doing what you think it should be doing. Because I think that's one of the biggest vulnerabilities of all is when you don't know what the code is and you don't understand what it's supposed to be doing, because that's when there could be some sort of vulnerability in there that you're like, oh, well, this code looks fine because I don't understand this underlying thing that I'm trying to do. Obviously, there's a flaw to that. Like, you don't need to go read like the Linux kernel just because you want to build an application. But I think like the bar is we've raised it a bit too high as far as like what we as individual engineers should be looking at. Like, I think you're right, Johnny. Like, people do need to be going into their dependencies and the dependencies of their dependencies to look at what's happening there. And if you don't want to do that, that's fine. But then import fewer dependencies or find a better way to do it. But I think that's where we need to shift as an industry as a whole, of like, part of this job is having to do the security stuff and having to understand like what is in the thing you're making. Like, you can't manufacture a product, you can't sell people food, you can't go out there and just spew things out there if you have no idea what's in the thing, right? It wouldn't be acceptable in most other industries to just be like, yeah, I don't know, there's just stuff. I can't validate this supply chain. People be like, that's not cool, that's not great. And I think we do criticize other industries when they do that, like the clothing industry, where it's always like, oh, there's some terrible labor practices going on, and like we need to fix this. And like, it's your responsibility as a company to know that this is happening in your supply chain, even if it's many steps removed from you. You should understand that that's happening, and you should remedy that as quickly as you can. And I think we're in the same sort of position where it's like, it doesn't matter if it's like a dependency of your dependency that's vulnerable. Like, you're responsible at the end of the day. So you need to make sure that your supply chain and your bill of materials is clean.
What's up, friends? I'm here with two new friends of mine from SpeakEasy, Sagar Bachu, co-founder and CEO, and George Hadar, founding engineer. So for the uninitiated, SpeakEasy takes care of the entire SDK workflow to save you and your team significant time, delivering enterprise-grade SDKs to your customers in minutes. You can generate best-in-class SDKs in TypeScript, Python, Go, Java, C#, and even PHP. So, Sagar, what's your excitement level for APIs and this API world we're living in?
I'm super excited about APIs. I think we went through Gen 0 of the API first revolution, and I think we're actually going to a second one now, with the tailwinds of the AI ecosystem kind of causing that to be reinvigorated. So yeah, super psyched to be working in this space right now. I think everyone's at a point now where everyone knows about REST APIs and GraphQL APIs and gRPC APIs. And now I think we're actually getting into the second phase of that, which is how do people ship great developer experience in addition to the APIs? And how do we build like truly best-in-class APIs that turn into long-lived infrastructure, right? This is kind of the vision, I think, that Stripe helped manifest for everyone in the fintech space, which is an API that really sets the bar for developer experience, but also like it's something you can truly rely on, right? It's a true, if you make Stripe a dependency of your company, you can feel confident doing that. And I think that's the part of API development that really excites me.
I agree. That is exciting. So, George, teams who leverage SpeakEasy are those who have leaned all the way in on documenting a solid open API spec and mostly want to be hands-off of their SDKs. Is that right?
Precisely. So you're coming to us because you want to be hands-off from that process. You want to put all of your effort into documenting your API, and then you're trusting and relying on great quality tooling to turn that into code and documentation, which is what we're doing for you. You're not meant to change or edit the code because it will be regenerated the next time you change your open API. So you ultimately put it in our hands. Once you've committed the changes to your open API, it's off to the races, and you get a new release of your SDK. You'll get a pull request to review. You will have the opportunity to look at the contents of the code, but quite often you can let it hum along creating SDKs for you or new releases of your SDK every time you change your API.
Very cool. Well, the thing that got me with SpeakEasy that really helped me understand it was that, as George said, it is hands-off. You can just focus on documenting your API via the open API spec. And you still have pull requests, you still have visibility. And in fact, they will even hop into pull requests with you to triage any sort of anomalies or issues that come from the SDK generation and improve the back end of SpeakEasy to make future releases better for you. I think this is so cool for teams who want to just be hands-off of their SDKs and focus on their product, focus on the core documentation around the open API spec, but still have all that awesome visibility. Okay, so the next step is to go to SpeakEasyAPI.dev. You can start off with one free SDK. That's so cool because you can go there right now and try it out completely free. One free SDK. Let them know the changelog sent you. Let them know JS Party sent you. Once again, SpeakEasyAPI.dev.
I'm going to be honest. I do not update dependencies until the bot checker comes out and says there's a vulnerability. Are you actually going through your like big projects like on a cadence and updating individual dependencies?
I've done that. I have some scar tissue for this one, but back when OpenTelemetry was the Go SDK, right, for OpenTelemetry was still so maturing. Basically, this was during my time at Heroku and the observability team. We were very early on in embracing OpenTelemetry at Heroku. So we got a lot of cuts, if you will, from the dependencies changing like constantly. Like, all of a sudden a certain package path is no longer, sort of around. And now we have to go find, where that particular, type is now located, or a particular behavior is now tucked into a different location. And we knew all this going in. We accepted, that there would be churn, and we accepted, we took that on and, tried to do our best to sort of, either contribute something back or, understand why things were changing to some degree and sort of insulate ourselves to some degree. But this was one of those things that the timing of it, right? We knew that we were going to commit to OpenTelemetry in the long term, for the long term. We didn't want to create yet some opaque to us only or mechanism only to us, because we needed to have better observability, but we didn't want to sort of commit to some sort of internal thing that nobody knows about, that, as team makeup changes, people come in and out, whatever it is, they have to now educate themselves on some, obscure thing. We're like, hey, OpenTelemetry, that's the standard, that's where the direction where the world is moving to. Let's embrace it. So we sort of, with our eyes open, we deliberately went in that direction. But there was a lot of cuts, right? A lot of paper cuts as we adopted and things kept changing. So yeah, this was one of the libraries that, I would go in and, update, right? As things change, and, then find all the places where a reference no longer, is valid and things of that nature. So yeah, everything else we tried to keep sort of to point versions only, just patches. But the OpenTelemetry stuff, like, we kind of didn't have a choice. We kind of had to, with every change, we kind of had to keep climbing up the ladder.
Yeah, and I do think that's a good idea with something is going to change. Like, doing a bunch of small changes over time is easier than one big breaking change, right? I think it could be interesting if we kind of red teamed this a little bit. If you were trying to get a vulnerability into a popular Go library, one, would it be possible? And two, how would you have to go about it?
The first thing I can think of is somehow, if you can somehow manage to get the vulnerability database or the SUM database, right, to maintain the same hash for the repository despite the contents of the repository having changed. If you can somehow do that, right, then you're golden. Because what would happen is you'd have...
that's interesting.
Yeah, because what would happen is the checksum sort of changes every time a new commit happens. So if you say, hey, version 1.0.2 in this repository, right, this commit hash, right, all the contents, everything about this repository at this point in time generates a specific checksum, and that goes into the SUMDB. And then now, all of a sudden, you manage to somehow, right, have the same checksum but having changed the repo somehow to include your malicious code. Then you're in, because everybody will just, the checks that happen is, hey, are these things lining up? Is the checksum and the security checks we have based on that, is everything lining up? Yep, you're good. But somehow we have new code coming in. That seems very improbable. But again, I mean, we're talking about the improbability of things here, right? Things that should never happen, but still happen.
Does it seem improbable? Isn't that kind of how Bitcoin mining works, right? Like, we're trying to append data until a hash matches what we expect. Could you not?
I mean, modern day cryptography is built on the assumption that it's not impossible, but close enough that collisions won't happen.
It might take a million years,
Yeah.
right? But you can do
think
it, right?
I think it's more of like a the XKCD comic where it's like, oh, like this person's used this level of cryptography, we can't get we'll never be able to break in, and it's like beat them with this wrench until they give you the password, right? I think it's like instead of trying to circumvent the system as a whole, like instead of trying to circumvent the computing system, you should circumvent the human system or find a vulnerability in that human system.
Right.
So, you find a
Right.
package that maybe has like, what happened with XE where, you have an overwhelmed maintainer and then you offer some help and you start doing things. And maybe at one point in some innocuous commit, you just sneak a package in, your own package that you control that's just kind of not doing anything particularly fascinating or whatever. And then it's just there for a long time and people just get used to it. And then after a while, you add some malicious code to that and in like maybe a little patch version, you just bump the patch version and then no one really notices, especially if this is a package you update like frequently. If maybe you're adding a bunch of stuff to it, maybe you're building it out a lot. So it just kind of slips under the radar, or maybe it's like a dependency of your dependency kind of gets some levels of indirection going. And then, that little you just slip a little vulnerability in there and then it kind of gets to everything. It's just like another routine update that everybody sees where they're, you can't go and look at the code itself because the code itself looks fine. It's like, oh, there's nothing, it put any malicious code into the main dependency that people are looking at. It's at some further removed dependency that might have gotten updated like a while ago. And now it's just gotten like trickled up. So you have to really like chase down a lot of that. I think that's like the vulnerability if you have a large package with a lot of dependencies where someone could sneak something like this in. But I think that's like a much more viable path than trying to like break modern cryptography.
Yeah, you'd almost have to hide it in plain. Well, not almost. You would have to hide it in plain sight, right? I think that's one of the kind of the advantages of how Go does things, right? Like for say a C program, you're often shipping like a tarball with compiled stuff in it, right? So you can hide whatever you want in there. I mean, you can, right?
I mean, hopefully it comes with a checksum. you can at least verify.
But it's not like it's not like you could hash your C code and make sure that what's in that tarball is what's in your C code, right? Because that's just not how it works. Like it's a precompiled piece.
Oh, you mean if you ship like a
DLL or
an SO or something, or
yeah, I don't actually know how it works, to be perfectly honest. But I know you're not shipping the C code.
Yeah, if you just ship like the object code and you're like, oh, just link this in during a compile process so that it's part of it.
Exactly. The fact that we ship the source code, we're not shipping precompiled bits. There's far less places to hide things, I think. So you really would have to slip it into plain sight slowly over time.
Yeah, I think it's one of the benefits, but it's like that also means that we can't really ship. Like the thing about like with C code, because I've like started learning C again, and one of the things I want to do is like be able to control one of my cameras with it. And Sony has like an SDK that you can use, and they just ship like the compiled like object, or maybe it's just a shared library. They ship like the compiled code for your platform to you, which allows them to like provide an SDK to everybody, but they don't have to necessarily open source it, which I think is like an interesting model for code sharing where it's like you can share the functionality without sharing the code. But that does come with the vulnerability that like, oh, well, now what you could put whatever you want in that, object file and it can do whatever. But you can also just use other code scanning techniques to find malicious code and things and other security techniques as well. Like, I mean, in your example you had, Johnny, where it's like, oh, if I just slurp up all of the environment variables and ship them off to somewhere, well, if you prevent your process from contacting random URLs on the internet, then yeah, sure, you've slurped up all the environment variables, but you can't send them anywhere because you're not allowed to contact some random server. So I think like also keeping in mind that there's other layers of protection that we can have so that even if there is some sort of vulnerability, we're not necessarily, it won't necessarily affect us is an important aspect of this. And I think like in the world of C, I mean, I'm not a C programmer or developer, so I don't really know how they do it, but like where you don't have the ability to necessarily look at all of the source code that you might be using, you are forced to use these other sorts of protective mechanisms. Whereas we might not be as apt to use those in Go because we can see all the source code. So we're like, oh, we can look at it. If there's something wrong, we can see that there's something wrong. So we might not, restrict our processes from contacting random servers in places, even though we we probably should. But that's like an operations thing, and that's usually a different department, and that's like usually going to be a little bit annoying, and probably some developer somewhere is going to get annoyed because they want to send some stuff to some random analytics thing, and they don't want to file a ticket with IT to open up that. Like there's a whole like there's reasons why we don't do these things. But if you're kind of forced to do it for the base level security, then I think that can help sometimes. But really, it shouldn't be like you should lock down your stuff by default and then make it easy to open things up for good reasons.
You don't allow your binaries to make random HTTP posts to wherever.
I mean, if I'm running production infrastructure, no. It's like, what?
I'm gonna take some notes here real quick. Might need to look at a couple things.
It's like, why does this thing need to contact some random server somewhere? Although, that once again it's like a trade-off because, engineers do love just pulling in. It's like, oh, I got to do this thing. I just want to get out of my way. I need to move. Let me get this, dependency and it does this thing. We're going to use this new service. It's like, have you vetted that service? Like, have you made sure that they're good? They're solid? It's like, no. We just got to get this thing done and out the door. I've heard that excuse a lot.
What is this package that you're importing with the blank identifier? What does it do?
Yeah.
I'm going back to like the idea of hiding like malicious code in plain sight in Go. And I just cannot think of how to build something in Go that makes a post request out without looking like it's making a post request out. Right? Like, or at least looking like what you're doing something weird here, right? Like there's just not that many ways to hide stuff like that. Like,
I mean, if you're clever,
I'm sure there is. I can't think of one.
I mean, the first thing in my workflow for validating things, right, which includes looking at pkg.go.dev and the metadata, whatever it is, if I dig sufficiently enough, one of the things that I do when I'm looking at repositories for some dependency that my dependency or like how many deep, right, I have to go. If I just do a quick search for HTTP, for the HTTP package, right, in the repository, if I find some, then I'm going to be very interested in this package and what it like this thing is supposed to be, I don't know, like flipping characters backwards or something. Why is the HTTP package in here? Like what do you what do you need? Like, I mean, you kind of have to be critical. Like, this package is supposed to do this thing, a very specific thing. Why is it doing network calls? Like what's going on, right? Then things like that should be obvious smells that you need to investigate, right? And these are what I'm talking about, right? Like, we can't catch everything, right? And no matter how, whatever our processes are that we think, oh yeah, we go through umpteen, different hoops we make people jump through so we avoid vulnerabilities. Security is a game of mitigation and sort of safeguards, and it's not something you can 100% sort of do, right? So part of that mitigation is as a developer, right, being you kind of the first line of defense here, right, and sort of being critical of these things. I'm importing this package. It's supposed to do this. Why is it doing that?
Yeah. Although, if we're red teaming again, if I was going to build some sort of vulnerability, I wouldn't use the HTTP package. I would probably just use like the OS package and do some syscalls to like set up the socket and then
syscalls.
Yeah, but exactly. You'd still be like, I would see that and be like, well, this looks strange. Like, why is this character flipping making syscalls, right? Like,
or, you do something and you say like, oh, yes, no, this character flipping needs to be super fast. So we've written it in assembly. And then you just do all the syscall stuff in the assembly. And then, no, you're going to be able to look at that and know what that's. It's like, can you tell the difference between flipping some characters around and and setting up a socket in assembly? It's...
I think I could tell. I really do.
Maybe. You don't know, Ian.
You are a giant among people, Ian.
I have a feeling that the length of that assembly for one would be much shorter than the other.
I mean,
but who am I to tell?
I mean, it depends, maybe there's some text blob you have somewhere else that's obfuscated code that actually, unrolls into some more assembly that does the thing. You can do some deep layers of this to really try and trick some people if you really wanted to. But once again, that's like a lot of work where you could just use a wrench instead. So it's there are other ways to exploit people.
Right. It's the obvious. Yeah. It's the obvious stuff you want to, like some things. I mean, if somebody is sufficiently motivated you're going to be hard pressed to find all the things. Right? It's the easy stuff, the script kiddie stuff.
Yeah.
Right? The easy, let me just use the HTTP package to send this stuff to my web server in my basement somewhere. Right? It's the easy stuff. You should at least be able to identify quickly. Then again, I'm sure there's companies out there that specialize in this kind of thing too, right? Like security companies, and they can scan your binaries and things. And I'm sure there are solutions you can bring into bear that you can pay for that do, like, if you really want that extra layer of peace of mind, to some extent, right? You can bring in those third parties.
Yeah. Because at a point too, it's like, oh, okay, well, I can't attack the code directly. Like, oh, you're running Kubernetes now. Maybe I can attack Kubernetes and get in that way. So it's like, as soon as you fortify one part of it enough, you can shift to use another part of it where you can get in and do this and do some damage. So I think to some degree, a lot of it's about like deterring, like doing lots of deterrence all over your system to make it like harder and harder and harder. So basically they go try and attack somebody else because you're too difficult and not worth the time. And then, hopefully we all start doing that and wind up in a better place, but that doesn't necessarily happen. You can't fix the industry all at once. But yeah, before we move on to the next segment, any last words on dependencies and vulnerabilities and all that?
A little copying is better than a little dependency.
Yup.
I did want to say that like Go does have a very good like securities data, like vulnerability database, and there are good bots to scan for those. And so if you just want like a first step, just put that in your CI system and update when it tells you. I think that'll go a long way.
Sounds good. And now for our favorite little segment of the show, Unpopular Opinions.
Unpopular opinion. I actually think you should probably leave. Unpopular opinion.
All right. Who has an unpopular opinion?
I'll reiterate mine from earlier. I think on balance, backend developers are more security conscious than front-end developers. Because, well, for a lot of reasons we just talked about, but the sheer number of vulnerabilities popping up from like the NPMs of the world and like it just seems to me like they're again, I'm painting broad strokes here, but to me it feels like it's too easy to simply copy paste, code components from frameworks, blah, blah, and then simply assume that it's all taken care of, right? Like you don't, some CDN, some library from some CDN here. Of course, that's what we always do in the community, right? Like there's a lot of assumptions that, oh yeah, everything is secure by default. I don't have to sort of pay attention to it. And very rarely do I hear sort of front-end folks sort of sweat those details. Not to say that there aren't folks, in those communities that do. I'm just saying that on average, over the last few years, regardless of the backend community I've been in, there's always some care and attention, special attention being paid to dependencies and security and things of that nature. I get less of that from front-end communities.
Yeah, I don't know. I mean, I definitely think that backend people, yeah, I feel like because so much security is like pushed onto the backend, like there's so much that needs to be done to secure it, and it's such a big target. I think it's like the people in the backend do tend to be a little bit more focused on that instead of the other aspects of things, where the front end people are just mostly focused on like trying to get the front end to like work and wrangling with, the many different browsers and all of the weird things that happen between them. I think there's also like a level of control that you wind up having more of in the back end than you do in the front end, right? At the end of the day, your code is running on someone else's computer on top of one of many browsers. It's just like a stack. You're just completely out of control. You don't have control over, whereas in the back end, you have a lot more control over your stack and everything that's happening with it. I
mean, I do think backend developers should be more security conscious, right? Like if you just think about the stakes, right? A backend vulnerability, you might release your whole database. A front end, like it might be one user, right? Like,
well, trying to go to JSTOR sends you to, casino.com or something, right? I mean, it's not, it's not nothing.
No, it's not nothing, and I do think both should be, but I mean, I would rather, if I had to have one of my users attacked, I would rather it be like individual users than my whole database, right? Like,
I think part of it also comes from the fact that like your backend code is within your security domain and your front end code is not, and you kind of have to treat your front end code as if it's hostile, like in all cases. So I think that kind of lowers the necessity in some cases of needing to be as security conscious about what's going on in your front end. And most of the time, a lot of the front end vulnerabilities like cross-site scripting can be blocked or prevented from like on the back end side of things as well. But I do think the kind of lack of security awareness for front end people, especially lack of cryptographic awareness, does hinder in some ways. Like I've noticed that there's not a huge amount of the use of the cryptography APIs in the browser, where that could be a much better way to do authentication and authorization, where you can like, because the browser has had APIs for years now where you can just create a public-private key pair that is locked into the browser, where like another script, even on your same domain, can't extract that key. And that would allow you to kind of uniquely identify that browser in a cryptographically secure way, and you're not passing around tokens that can be lifted kind of no matter what, and someone can run some JavaScript on your website. So it's like, yeah, there's a little bit you can do through cross-site scripting if you can still make API requests, but you can't lift that key and send it to a server and start making a ton of requests or anything like that. Whereas you can do that with the bearer token. And I think some of the reason that's not done is because there isn't as much of a familiarity with these tools and these ideas in the front end community. So there's not a lot of support for this type of stuff. I mean, we're starting to get it with things like passkeys, but that is like super late compared to what we could have had if we tried to start doing this much earlier.
That's not the unpopular opinion. I don't know how passkeys work. I keep getting like every website I'm using starts saying, "Hey, use a passkey." I'm like, "Oh, I might have read something from Microsoft once upon a time."
Yeah, to massively simplify it, it is just what I described. It's asymmetric cryptography, so it's a public-private key pair. And then the public key gets registered with the server. And when you go to sign in, it signs a thing and it sends it to the server. It does a whole dance to confirm that you actually have the passkey. There's a whole bunch of other stuff that needs to get done for things that are like shared passkeys to like actually move them around between different places. But at its simplest, it's public key cryptography applied to the authentication process. So yeah, it's a lot like what we do with SSH or with a ton of other things. Or TLS, you use mutual TLS, does the same sort of thing. So it's just applying that to the browser. Yeah, no, passkeys great. I love passkeys.
Great, except nobody knows how to use them.
I mean, that's
like the setup process. I went through the setup process a couple of times. Like I couldn't tell you what happened during the setup process. Like it was slightly different. When I did it for Google and Apple's now doing it to me, and I've done it with Microsoft, like they seem to be slightly different, or at least the experience of them helping me set up a passkey seems to be slightly different. Sometimes with my phone, sometimes with my laptop. Like I don't know how, honestly, I don't know how it works. Maybe in a few years,
because like I use 1Password, right? And so that's just all integrated.
Yeah, so do I. Yeah.
So like 1Password's just like, oh, I see you can set up a passkey. It's like, would you like to set up? You click a button. It's fundamentally the same thing we were doing with YubiKeys, right? Where it's like that. I think the workflow, the flow to set up a YubiKey is the same as the flow to set up a passkey. They're effectively the same. But yeah, it's slightly different on different platforms, but it's fundamentally doing the same thing of being like, here's a public key that identifies me. Okay, great. And then moves on. There's a lot of nuance and there's a lot more details than that, but that's effectively what's happening. You're giving them a public key that identifies who you are, and then they ask you to prove it later. But yeah, it's. I mean, I'm glad that we're kind of trying to retire passwords. That makes me very happy. But it is.
Listen, passwords are going to be the fax machines of tech. They will never go away. Never.
I mean, yeah.
Somebody somewhere. It'll be like your old dentist, doctor's office or something. You need to send some proof of insurance, blah, blah. And they'll be like, can you fax that to us? I'm like, what?
Yeah, it's
What do you mean?
it's like, will we be able to?
You think I have?
We'll be able to.
I have a fax machine lying around?
I did have to fax some things to the government, and I was like, fax? How am I? Okay. The passwords will never be completely gone, but they can be effectively gone for the vast majority of things, right? We've had social sign-ins for a long time. Now we have passkeys, and like, you have password managers now, which is like go use one of those. Don't.
And only now is general non-tech people starting to understand what they are and why they should use them. Like, I don't expect my mother, right, bless her soul, in her 70s to know how to use a password manager. You kidding me? Like the amount of hand holding that I would have to do, right? I have to tell her, like, look, use a random password for every website. Yes, I know it's painful, but like keep those things safe somewhere on your phone in a notes doc or something. And then just don't use the same password everywhere, and be very careful. When anybody at any point asks you to send them a password, like, call me right away.
Yeah.
Like, these are the safeguards that I have, right? Because I can't expect her to use a password manager. That's way too sophisticated or complicated.
Maybe it's an unpopular opinion, but I think anybody that can use a computer can learn how to do these things. I think we introduced them too late. Like, if we had started with this passkey revolution 20 years ago, like we could have, I think everybody would be used to it. Be like, oh, like, why are you still using a password or something? That's so weird. You should be using this other thing that we have. But like, we just didn't build up the infrastructure. I think the main thing for the thing that's pushed passkeys forward is like the biometrics in our phone and on our computers, where it's like, now you can actually confirm that the person sitting at the computer is who you think it is within a degree of certainty. But yeah, I think that, a lot of this it's hard to understand because we're bad at explaining it, not because people fundamentally can't understand it. Like, I'm sure your mom doesn't remember every single person's phone number. I bet she's figured out how to use the contacts app in her phone and put all the phone numbers in there and just be like, oh, I'm going to call this person. Let me click on their name in the contacts app.
I would disagree with that.
Your mom knows she has a phone number of everybody she's ever met in her head.
No, just a bunch of random numbers in her text messages that are like, I don't know who that is, but I talked to him.
Jeez.
I mean, there will always be some people that.
Wow.
It's not my mother I have specific in mind, but I have someone specific in mind.
And that's not there's some people that'll just do weird things like that. Like, that's. It's like, oh, this is somebody's number. I don't know whose. But I would say the vast majority of people understand how to work their contacts app in their phone, which is effectively a pretty similar thing. It's like, oh, you go look up in your contacts app, you click. It's like, okay, go look in your password manager and click this thing. But yeah, I get it. Okay. Okay, that was a tangent. Ian, do you have an unpopular opinion?
Yeah, this one's going to be very unpopular. It's related to what we talked about. I don't think you really need to update dependencies until you have a reason to.
I mean,
that's it.
Yeah, that's.
I mean,
that's fair.
I think that's literally you only need to. I don't know how that's unpopular. What do you mean? You think we should just update our dependencies for no reason?
I mean, yeah,
people do that. Yeah,
people do that. People like go through monthly and update all their dependencies.
Yeah,
and I think that's a waste of time. Unless you have a reason to, unless there's a known vulnerability, I don't really think there's a reason to actively update your dependencies.
Well, I mean, unless it's like, the API is changing or you need some new feature. But yeah, if you just go through to update to keep everything updated. I mean, to be fair, I would say, or maybe to counter that a little bit, I would say I'd prefer if especially enterprises did that as opposed to what they do, which is never update anything. And then there is a vulnerability and then they don't update it and then they get hacked. So I'd much rather if they had a process in place to always update everything. And at least then, when there is a vulnerability, they know how to update things. Because there is a risk that if you don't update things often enough, then you might not know how to when you need to. So kind of the reason we do fighter drills is because like you need people to know what to do when there's an actual emergency, and the time to figure that out is not when the emergency is happening.
And I don't believe this in other languages. Like if I was doing a JavaScript thing, I would be like, yeah, I should probably update these every once in a while because I don't know if you've ever not updated React for 5 versions and then tried things don't go well. Right?
Might as well throw out the whole project and start again.
Yeah, start over. Yeah.
Let me specify it. For a Go project, I don't think
okay,
you really need to proactively update dependencies unless there's a known vulnerability or you need a new feature.
That yeah, a lot of that's going to depend on sort of the discipline of the maintainers of the projects that you're on. I've been in situations where a security patch gets made to a version of a particular dependency that the patch has been added to an upgraded version that I was not using. And that meant if I wanted the patch, right, I had to upgrade and then get the patch, right? So if they're not disciplined enough, or maybe they don't have the resources, to be frank, or the time, right, to patch every version, right, with that particular thing, which is labor intensive, right, then your best bet might be to sort of a forced upgrade, which could introduce breaking changes to your stuff, right, before you can actually get the patch that was applied to the appropriate feature that the level that you're trying to upgrade to. So you don't always have the choice. Again, it's you're kind of at the mercy of your dependencies, which is why I don't like to have that many of them.
This is also coming from someone who has very few dependencies in any of the projects I work on, so I might be biased.
Good for you. You are blessed.
Okay.
Yeah.
So, if, my unpopular opinion, I feel like this is probably going to be very unpopular, but I think everybody should learn C. Maybe not write everything in C or write a lot of stuff in C, but I think everybody should learn C. I think that's a thing that we as an industry need to do, because I don't think people understand nearly enough how any of this stuff works. I think too many languages do a very good job at hiding all of it from you.
What about C specifically? Like, you do your own memory management, or like what do you want them to get out of it?
Yeah, I think C is one of the few languages that is just like basically touching the metal, right? It's like right there. I mean, the lowest you can go is like assembly, right? Unless you're trying to hand code machine code for some reason, which is, but like, there's like assembly, and then right above it is C. So you get a lot of the nice higher level facilities that you get in other languages, but you have to understand how the machine works to write C, or even to learn C. You gotta understand like what this memory model is. You have to understand, how your actual instructions are kind of flowing to at least some degree if you want to write C, or in other languages that don't have this procedural level to them, where they're more object oriented and things are more abstract. It can be more difficult to understand how your machine is actually functioning.
Mentioned. So personally, ever since I've been doing Go, I don't miss OO. And some people will say, "Oh, Go is object oriented." I mean, that's a debate that's kind of gone on for quite some time. But I think writing Go feels more like writing C to me than any other language. So I'd say, yeah, if you've never done C, and you want to know what it was like, or what it is like, even still for some people that are still writing C code, then yeah, definitely, take a peek, right? At least do a hello world or something a little bit beefier than that, right? Just to give you an idea and see what it's like to actually do your own memory allocation and freeing. Like, get a feel for what it is that you benefit from a more modern language, for sure. But as far as sort of object orientation, like multiple layers of abstractions, abstract types and all these things, like I don't really miss those things. The most abstract I ever want to go in my Go programs is like using an interface or something. That's the extent of OO I ever want to do, abstractions I ever want to do.
I was gonna say, I'm not sure I agree everyone should learn C, but everyone should try, like, I don't know, like a C style language, like Go, C, something like that. And I say this like as someone who wrote in PHP and JavaScript for the first couple of years of my career. I had no idea that like an HTTP request was just like bytes over a cable, right? Like you're working as in JavaScript you have objects, and in PHP you have these like big associative arrays. And I was like, I had no connection of how those got switched between each other, right? They were just objects were just what they were, and I had no concept that everything is just bytes, right? And you make a lot of silly mistakes when you don't like have that core concept. So doing something at a kind of just a lower level, I do think is important, even if you're only going to be working in those like higher level, more abstract languages.
Yeah, I think like the reason I think C specifically, I mean, C is like the lingua franca of all systems out there. Like if you want to talk between two languages, you're doing it through C at the end of the day. But I also think like maybe if there was another language that we had that was like just could show you more of the fundamentals of how machines work, that would also be helpful. Because I think like one of the things with C where it doesn't have anything. It's not like in Go where you can just be like, oh, I'm going to say Go in front of my function and it's going to go spawn a Go routine and yay, concurrency. It's like, no, you have to figure out how that works for what you're trying to do and how multi-threading works. But also like, you know, you need to have some awareness of like, you know, what is a cache line and how does my CPU work and how do all of these things work? Where I think like enough people don't understand that now, and we write really bad software as a result.
Because we've been told we have unlimited memory, unlimited disk space, unlimited CPU. You know, just throw another vCPU at it, right? Like we've been trained for, you know, in the cloud era, we've been trained to just think, oh yeah, don't worry about these things. Just we'll throw more hardware at the problem, right? That's and back in the day, we didn't have that luxury, right?
People also do this with like, you know, we talked about memory management, but it's the same thing with like garbage collection. You know, so the whole thing of, you know, that line of like, oh, we have a garbage collection problem. It's like, you don't have a garbage collection problem, you have a garbage problem, right? You're creating too much garbage for your garbage collector to keep up with. You're just making too many things and throwing them away. And I think like there's still this persistent idea that like you don't do memory management in languages where you aren't doing manual memory management. It's like, you know, you still need to do memory management. You still need to think about your memory and how you're laying things out and what you're doing with them and how many of them you have when you're designing your application. But yeah, I think, you know, by going into the depths of C, I think you can learn a lot of this stuff and have enough of a familiarity to kind of to be better at the higher level languages.
I don't disagree.
All right. Well, that's it for today, folks. Thank you for listening. And, you know, make sure that your dependencies are all in check. Don't have any vulnerable code running out there, please. Pretty please.
And do a quick grep on all your front ends. If you have polyfill.io anywhere in there,
yeah, get that out.
Run.
Get rid of
Do
that.
not walk. Run to your closest VCS.
Even if you're doing a Friday, so this is a reason to deploy on a Friday.
Right.
Anyway, thank you for joining me, Ian and Johnny. It was a great time, and thank you, listener. And we'll catch you next time.
Bye, y'all.
That is Go Time for this week. Thanks for listening along. Subscribe now if you haven't already. Head to gotime.fm for all the ways, or simply search for Go Time wherever you get your podcasts. You'll find us. Hey, do you receive our changelog newsletter each Monday? If not, let's fix that bug. One reader calls it so good, he considers it a competitive advantage. Sign up for $0 at changelog.com/news. Thanks once again to our partners at Fly.io, to our mysterious beat freak, Breakmaster Cylinder, and to our friends at Sentry. We love Sentry. You might too. Use code changelog when you're signing up for a team plan and save $100. Why not, right? That is all for now, but we'll talk to you again next time on Go Time.